So it's
Long time.
something that we have to consider. Stay tuned, and I'll have a discussion about it in observations. And anybody, of course, that wants to weigh in on it can contact me or any member of the exec committee about it. Especially Bea. She loves to hear about this stuff.
Oh, indeed. Yes. It's what I live for. My COVID dream.
And with that, I'm going to turn us over to Dawn and Boo, who I thought was in the background there just a minute.
She's here. She's here.
And talk about what's up for this month, although I think we already know what's up.
Yep, I'm actually going to change rather than doing a stellarium look. And if we could, if you're not actually speaking, everyone could mute themselves. I'm hearing some background noise coming in, so if you can please mute. And if you want to ask something, all you have to do is press your space bar. That will temporarily unmute you. But if everyone please go to mute, it would help. There's a lot of racket. So I'm going to do something a little different. First, I want to show you a movie that a fellow from DVAA produced, and he took this from his home down in, I guess, in the Radnor area. Can everyone see this? Can you see it? This is a movie he made with a 11 Celestron and a Canon DSLR camera. And I think it's amazing what he did. He stacked a lot of images with AutoStacker, processed it with Registats. So this is just amazing images. That's pretty much what Mars looked like to me in the eyepiece. Maybe a little smaller than that, but it looked like to me in the eyepiece. So it's an amazing, amazing image. The other thing I'm going to do, rather than do a night sky, we're going to go and take a look at Mars. We're going to do that using Mitaka. So if this starts to lag, let me know. Sometimes it will, depending on the connection. So we're going to take off from Earth. This is Mitaka software from National Observatory, Japan. It's an amazing program. So there's the Earth. Going to spin around, and we've spent some time on Mitaka already. I'm not going to talk much about the program. So I'm going to target, I'm going to go with scale of 1 AU. And I'm going to target the sun. And we're going to look at where we are right now. Let me go to time, real time. So here is the Earth, and here is Mars. And as you can see, tonight, October 13th, is opposition. It is the only day that Mars is on the opposite side of the sun from Earth. So sun, Earth, you can draw a line straight through the three of them. I do like to mention, I'm going to go change my time here. So I'm going to go back in time a bit. Let me change my time to like 4 hours. Go back in time. A lot of people say, well, why do we only have a chance to fly things to Mars every 2 years? I'm going to go back to July. So here's July. Here is when the United Arab Emirates and NASA and also the Chinese, 3 probes were launched to Mars. And watch what happens. They're going to arrive there in February. So they're flying through. You can't fly to Mars directly. You fly to where Mars is going to be. So that's where Mars is going to be sometime around there when they actually get there. This is what makes it so hard to get astronauts to Mars, because if you get there, then it's too far to get back. You can't get back. You have to wait 2 years to get back. So that's why if people fly there, they don't have to wait until, this had been astronauts instead of probes. I have to wait until 2022 to come back. So that's what's so hard to get to Mars. So I'm going to center on Mars now. I'm going to zoom in, and we'll take a look at Mars. So if you haven't seen it in the night sky, please do. It is unbelievable these days. And now, these are the 2 moons, Phobos, and I looked this up and actually researched the pronunciation. It can be pronounced Deimos, Deimos, or Deimos. You take your pick. I found all 3 pronunciations. Here is Mars. There's some, and you have to go in Mitaka, we can zoom in and it actually identifies some of the objects. The polar cap is really cool to see. It's tiny, and this is not far from what it is now, maybe a little larger than that. It's really fun to look at. I'm gonna just take my time back to like 4 hours or so, or 1 hour, and I'm gonna zip around the planet. I have to go back to 1 hour. So this, I don't know how you pronounce this, but Saturday Major, that is what I was looking at on Friday night. Is very, very easy to see. I was not able to pick out anything else. That was the biggest thing you could see. I do want to show you one other thing. Olympus Mons. Olympus Mons, as far as we know, is the tallest mountain in the solar system that we know of. The Mount Everest is about 29,000 feet high. This is about 85,000 feet high. It's 25 kilometers compared to 9 kilometers of Mount Everest. And Mars is a lot smaller than Earth, so that thing just towers over the planet. So anyway, I just wanted to focus on Mars tonight. I'm not going to do any of the rest of the night sky. It's such an amazing view right now. And I want to leave plenty of time for John's presentation, because I know we're all looking forward to that. So I'll turn it over to you, Bruce, to introduce John.
Okay, Bruce, you're up.
Okay, so thanks everybody. Yeah, we're glad to have John on tonight. And as I guess everyone knows, John is a member of CCAS, and he's also one of the 3 NASA ambassadors that we're privileged to have in the club. So most of you probably know John has a background. He went to the Air Force Academy in Purdue, and then he worked his way in aeronautical engineering, and then he worked his way up to work for the Air Force, the Department of Energy, and then I believe he worked for Lockheed Martin in various aspects of the space program. So I've been fortunate that between CCAS and the Planetary Society, I've heard John give a number of incredible talks. And the one that he's going to talk about tonight, I heard about 2 years ago, and it was really amazing. Actually, it was disturbing in a lot of ways. And he's going to provide us an update tonight. So this is a timely 2020 update, Global Climate Change, the View from Space. So John, without further ado, break a leg. Well, not really, but you know.
Thank you very much. Let's see what we do here. I'm going to share my screen, and let's see if this works. Can anybody see anything?
Yes, it looks good.
Good, John.
Okay, good. I'm going to unclutter my stuff, so give me a minute here to get stuff out of the way, because I don't want to look at you folks. Then I won't have anything to say. Let's see. There we go. And Don, if I may ask, you and I talked briefly about people getting questions into the chat.
Yeah, Dave and I will monitor the chat, and we'll interrupt you if it seems to make sense to interrupt you, okay?
That'd be great.
So
All
if
right,
anyone
so,
wants to, the bottom of the screen, there's a chat, little balloon there over chat. You can click on that and type a message to everyone, and we will watch that for questions there, okay?
Okay. First of all, let me thank the Chester County Astronomical Society for being willing to invite all the other clubs in the area that I talk to on a regular basis. Hopefully there are plenty of folks that were able to find the time for this on YouTube as well. So I want to start off, and you're staring at pretty much the same screen that each of the clubs got briefing on anywhere from 3 to 5 years ago, I think. And so what's happened is in about the middle of the summer, when, I don't know if this was something that you folks would have noticed, but I noticed that climate change had left the vocabulary and left the media for the most part. And I thought this would be a good time to try to update myself first and then decide if there was enough to say about things that have changed since the last time we looked at it. Because for better or worse, in my view, and I think many other people's, this may be one of the #1 challenges of mankind right now. So without further ado, we're not just going to do last time's talk, we're going to update that talk. And if I can get my changes to go here. Not sure what's going on. Here we go. There we go. So we're going to talk about the 2020 update, and we're specifically defining it as those things in the 2 major areas, what's going on with the climate and what's going on with not just NASA, but around the world from space to look at it. Not just right today, but what has changed and where we are under the current administration as opposed to prior to that. So that's what's new means. And when we get through that, we're going to talk about what's next, which is hopefully going to be of some interest to you. I will, for example, at some point talk about NASA priorities as reflected by budgets. And I might even mention our dear friend COVID, who's the other force of nature that we're having to deal with these days. All right, so this may look familiar to you. My favorite website, if you want to actually know the facts about climate change, easy to remember. You go to this homepage at the bottom. It changes on a regular basis, and always across the bottom is the very latest of the 5 key parameters: CO2, temperature, the ice cap, the ice sheets, and the sea level. And so we're going to look for just a second here and remind ourselves of how the temperature turned upward pretty much all the time by the beginning of this century. And it's been actually accelerating somewhat to where we keep setting records. And so the last time I talked to Bruce's group, this is where we were. And now that we've gone a couple of years further, we've actually found that we have 18 of the last 19 years were records. And we have found this summer was the hottest ever for the Northern Hemisphere. So the heat and the height, or the increase in heat, continues unabated. We do have global warming. As before, we talked about the greenhouse gases. The key is to remember that we're really happy to have greenhouse gases because that's why we're alive. It keeps us alive, to have that warmth held down on the Earth. But we don't want them to get too thick, like maybe on Venus and some other places, and the heat to run away. And so we have to watch out for intensification. And you look here at this curve, which I've now extended out beyond where it was, and we have 16 straight years that look like this. And not only the CO2 has been going up on a steady basis, but now we have another one that's been coming into the news more, and that's methane. Another principal greenhouse gas, a growing problem, as you'll see, because we're going to talk about that tonight. But you don't want to count on, some short period of time like 16 or even 50 or 100 years if it turns out that these curves go up and down on a regular basis. So we want to look at the historical context. So we'll look back over 400,000 years. And we can do this with ice cores. The paleoscientists can do amazing things these days. And here we have this remarkable thing where for 400,000 years, or the better part of it, things went up and down in a fairly regular envelope in terms of parts per million CO2. And then we left that envelope and went an equal amount up in just the last 70 years, actually more than it had been in terms of excursion. So the rise of CO2 is pretty alarming. And on the time scale of this graph, which compresses everything, it looks like we're going straight up. So we add that greenhouse gas constantly. What causes it? Here we have a nice photo with pretty much every kind of thing that gives us fossil fuel burning, from trucks and cars to chemical plants to electric generating plants of various kinds. And so lots of human activities. Not news, as we said, Alexander Graham Bell over a century ago looked at not just the kind of early birth of the motor car with a fossil fuel burning engine, but the fact that the assembly line and mass production had taken over. And he said, oh my gosh, are we going to get a lot of CO2? And he warned us and said, start thinking about solar. So this is testimony to how slow humans are to actually consider even beginning to change. But at any rate, it's not news. The chemistry of the atmosphere has been understood for a very long time. All right. In addition to those activities, equally damaging on the other side is what happens when we can't get the CO2 out of the atmosphere as much with the vegetation, which has always been convenient in that that's what photosynthesis wants. Take in the CO2, breathe out the oxygen. And so you've probably heard the Amazon referred to as the lungs of the world. Unfortunately, we are clear cutting lots and lots of forests. Lots of deforestation means lots of CO2 that is not removed from the atmosphere. And I just want to kind of give a plug here for a local successful group at a company called GE Aerospace, which not all of you may know are those buildings above the mall in King of Prussia, which today say Lockheed Martin after the industry consolidation. Landsat, known as Earth Resources Technology Satellite 1, ERTS-1, was built at the beginning of the 70s. It won a huge Collier Trophy Award because it was viewed then to be such an important thing. There have been Landsats flying ever since, and the Landsat data stream with images like you see here is the longest standing continuous data stream that we have. So you can give a nod there to the local people. All right, so I said I'd mention methane. Methane, unfortunately, is, even though not nearly as much of it is being emitted into the atmosphere, it's much more potent in terms of trapping heat than CO2 is. And so there have been quite a few studies of this lately because it's been growing in terms of concentration, and it's been recognized that it is so much more effective at giving us global warming. Lots of studies, we've learned such things as this, which I didn't know until I put together this talk. Fully a quarter of the man-made global warming is caused by methane. Another recent research put out this year, toward the beginning of the year, has found that we have grossly underestimated the human contribution to this. And even though it sounds like totally bad news that most methane emissions are man-caused, the good news in there is that since they're man-caused, we can actually exercise our willpower and then specific things and get about fixing this. And the fact is that the good news continues with the fact that unlike CO2, which has great lasting power in the atmosphere, 100 years or more, methane is very short-lived. And so you put it in great quantities and it takes care of removing itself by various processes before long. But the fact also is that if we can find where man is, if you will, leaking all this methane, as opposed to nature, which contributes some too, then perhaps you can have an impact on decreasing the methane that's been growing so fast. And so an example of that came about in a study a couple of years ago published in Science that had surveyed and found that the oil and natural gas industry, surprise, surprise, was actually putting 60% more methane into the atmosphere through leakage than the EPA had been reporting. The authors suggested why this was, that we didn't know it, but the fact is that we can tighten up not just the inventory of what's going into the atmosphere, but importantly, we can tighten up such things as leakage from fracking wells. The regulations were already put in place to say you can't put methane into the atmosphere. A fracking well, which produces, we believe, natural gas, which you may or may not know is pretty much the same thing as methane, they are letting a lot of it leak out. And so hopefully the good news will be that with really strong regulations and tracking and enforcement, we can get a handle on this, literally cap it, and start getting this new threat out of the atmosphere. Another way to look at it now, looking at something that isn't directly man-caused, but caused by nature, is to look via the other kind of observations that NASA makes, which is with aircraft. The A in NASA is for aeronautics. And so they have quite a fleet of aircraft that do operation or observations like their satellites do. In this case, here's one particular expedition that they sent some aircraft with instrumentation north to take on, I think, for 3 or 4 years since 2016. And they started by looking at the northern Alaskan and Canadian forests, which are huge expanses. You're probably aware of the boreal forests. And they wanted to measure carbon released by fires and the permafrost that was thawing. And once they got into it and discovered how much permafrost was melting, they used the spectrometer to cover a very large area and basically map the methane hotspots and find 4 million of them up in the northern forests. And so what does that mean? Well, if you have permafrost thawing, it releases carbon, which the microbes digest, and that process releases the methane. So you thaw permafrost, which in typical areas throughout Alaska can be down 6, 10 feet. And now with global warming, the surface is now moving that line of permanent ice down further and further and releasing this. And so we have lots and lots of methane coming up. And here's a good way to get kind of an idea of the methane released by permafrost by looking at the top of the world here, where you see the North Pole there in green. And all around it, on the either side of the Arctic Ocean, you've got on the right the top of Russia and the Scandinavian countries, and on the left, Greenland and mostly Canada and a bit of Alaska. And so you can watch in this as this imagery and the animation of the European Space Agency's Sentinel images is animated as we go from 2003, and the white area, which is continuous permafrost, and the blue somewhat sporadic, you can see it just shrinking year by year. That's an awful lot of methane being released into the atmosphere. Again, this is the way nature works, but nature is working that way because mankind has been responsible for warming the atmosphere. And so we got a real growing problem there, in addition to what some people like to refer to as methane released by various digestive processes. All right, so let's move on. So in order to study global warming, the scientists long ago came up with a simple construct in order to sort of divide and conquer. And so we've got the 4 spheres: the atmosphere with certain dynamic parameters, the ecosphere and land, the ocean or hydrosphere, and finally the ice world, the cryosphere. And so each of these has dynamic things. In order to understand what's going on with regard to a changing climate, there's a lot of complexity to getting enough data and then tracking things in any one of these spheres, let alone putting them all together. But all climate models have to address all of these. And the salvation in terms of knowing what's happening as extreme weather comes on us and heat comes on us, which we might not know as well, is that the space age came and we learned how to put spacecraft into polar orbits so that the Earth can rotate underneath and give us this complete coverage 24/7. And so we've got these climate models, and who is it that oversees most of these important ones? It's this agency I told you about that's been in the news quite a lot, the Intergovernmental Panel on Climate Change, set up originally at the behest of some Republicans and Democrats in '88 under Reagan, that agreed we had a real problem with global warming and went to the UN and helped get this established. And so this agency oversees literally tens of thousands of scientists and experts around the world, because many countries, you see there are 120 countries, it may be more now, this chart's a few years old, but at any rate, they publish their findings with projections and model results every 3, 4, 5 years. We're due for another one because the last one was in 2014. They've been recognized by the Nobel Committee as being really important with the Peace Prize addressing man-made climate change. And so the way they do this in terms of giving answers, yes, to the world's decision makers is by running these complex models that I've been mentioning. So they did an inventory, they did a peer review of various models around the world that purported to be tracking and modeling the way the climate works, and would therefore require lots and lots of data input, and would require that they were able to deal with all of those four spheres. And so you see the four spheres there, and you also see an orange coupling, which is another model. So you basically have all of these models, a couple dozen at roughly at different research institutes across maybe 15 different nations of the world. The US has several at NOAA and NCAR and NASA and so on. And the Chinese have a few, and the Japanese and the Russians and the Europeans and so on. But the coupling there in orange is a really key ingredient and perhaps the hardest part, because what you're doing there is writing some rules to handle the dynamics, to tie together things like the winds blowing across the surface of the ocean and what impact that might couple into the ocean in terms of currents or thermoclines or something like that, as well as the oceans coupling into changing the cloudiness in the atmosphere, which changes the solar insolation and so on. So a lot of complexity, lots of thousands of scientists have been running these now for decades. They're getting quite good at it, I'd say. And one of the things along the way that they did was discover that to talk to people that were in senior positions that needed to make decisions, they needed to put it in terms of, if we stopped all of this right now, in 5 years, this would be the case. Or if we stopped it, if we didn't stop any of it in 10 years, what would be the case? And so they set it up as projecting scenarios, which requires them to project the human response to things like being told you can't buy any cars other than this kind, or industry being told you can't build any more of those anymore. So they brought in sociologists and econometricians to run the economic side of the impact and so on. And complex things got even more complex, but that's what's needed in order to tell the people that need to lead, if you will, and tell their nations what it is we're going to do and why. So they're hard at it still, and we're very thankful for them. The view from space now, in terms of what we have and what's changed. So here's a nice way to get an idea of how a polar orbiter works, except for those Cygnus that are at a lower inclination. All the other down-looking NASA spacecraft here are in specific orbits where the Earth rotates underneath. The orbit is about 15 times a day at these altitudes. And so you get about 100 passes a week of the Earth, and over a period of time, your instruments cover everything that they can see, whether it's seeing down on the surface, whether it's measuring things in the atmosphere, or whatever. And you can't imagine what genius it was that put together that rotating in the wrong direction Earth. At least I can't, but at any rate, there it is. And so here we go around again. All right, on to the next one. Here's another way to look at the spacecraft that are now flying and contributing by design climate change parameter data. And so these are almost the same as the dozen that I showed a few years ago. A couple of those were retired and a couple new ones have been added. I don't need to trip through those. I'll just point out again that each of them has at least one major part of climate change data that they have instruments that are measuring and contributing to the modeling. For example, the GRACE spacecraft, you may remember, is a constellation of 2 spacecraft that sense gravity and therefore can sense the mass of ice caps and ice sheets and so on. The third one over in the top row, its name says what it is: soil moisture, active, passive. It's obviously very useful for looking at drought around the world and so on. Each of these having its own focus in terms of climate data. So that's NASA satellites. And in some cases, actually 2 of them that I have there in yellow. In the case of GPM, it's Japan. In the case of GRACE, it's Germany. So those 2 are joint, but they're led by NASA. But I want you to know this time, which I didn't say last time, that there's an awful lot of non-US satellite activity because it's a global problem. For decades, just like the US, the other space agencies have been addressing this too. And so India, for example, has Earth observation sats, we'll just call them EOSats, all the way back to more than 30 years ago. 9 of those have been designated as their climate and environment measuring satellites since 2002. China, they don't share all of their information with us, but they've got a lot of these down-looking Earth observation satellites. And one that's particularly good that they just launched in the last couple of years is called TANSAT, which apparently translates as carbon satellite. And oh, I see, it's 2016, time flies. At any rate, it does almost exactly the same thing in almost exactly the same orbit as the NASA Orbiting Carbon Observatory 2, measuring sources and sinks of carbon around the world. Japan, again, going back into the 80s, has had many Earth observation satellites. They have a special mission named Global Change, and a couple of their more recent satellites, GOSAT and GOSAT-2, which was just launched recently, not only measure CO2, but also methane. The Europeans usually band together as the European Space Agency under the EU, and they have a major program from the 90s called the Copernicus program with the Sentinel spacecraft. And the 6th of the Sentinels is about to be launched from Vandenberg next month. So at any rate, they're monitoring all 4 spheres with their various Earth observing satellites. And other nations listed here also have Earth observing satellites of various kinds. So I want to remind us all that it isn't just the measurements that we're taking from 200, 300, 400, 500 miles up. It's things that are much closer to Earth. And so NASA has long had a fleet of aircraft. In the corners there, you can see Global Hawk and Dragon Eye, and there's another drone. So several of them are drones, and the ones in the middle are manned aircraft with various altitude and duration capabilities. And these are only the NASA aircraft for Earth science. There are a number of other aircraft for astronomy and other things. So NASA does a lot of flying to do observations as well. And here's an example here for airborne campaigns showing the orbits of the aircraft that flew distinct planned paths in order to gather data of various kinds. Why? One of the key things that they can do for you is from time to time, they can take the same measurements down close to the Earth or actually in the atmospheric area in situ of things that you're trying to measure precisely from space and give you much more precise readings so you can calibrate the spacecraft observations. And also you can see things from aircraft like plankton that you can't see from on high. And in the case of climate change, it's particularly good at looking at the ice sheets and the glaciers, especially now that we can measure the mass of these things with GRACE. And in addition, finally, NASA uses ships for expeditions sometimes to take measurements. And here's a Coast Guard ship actually, but it's supporting a NASA mission. NASA actually has their own research vessel as well. And I love this name. I mean, oh my God, what a great name. OMG, Oceans Melting Greenland. And so the people from that expedition talks to us and told us about how they are doing surveys along the coastline of Greenland in order to give us very precise information about the front of the Greenland ice sheet as it melts and breaks up from the glaciers into the ocean, contributing to sea level rise, of course. All right, so it's kind of mind-boggling when you think about the literally dozens of Earth observing satellites. Remember, 105 orbits a week, roughly, each with at least one, maybe multiple instruments with data streams that are constant, contributing these to databases. And so this is truly big data that we have now. And so the questions become pretty obvious since the data is captured by instruments designed by different nationalities and different companies in different nations. It's really, really important, as it is in all area of digital data, to have standard set formats, to even have a way to talk to each other, that is to say a lexicon, so that when you refer to this particular band of the spectrum or that band, you're all using the same words or translating it the same way. So getting a hold of this is something that requires quite a bit of work. I did some of this in NATO back in the 80s when we were trying to work on interoperability of various kinds of military systems and their data outputs across countries. So I know how hard this is. So you have to have some organizations that are set up to do it. And I was very pleased to learn, and I just learned it by my research to prepare for this, that in 2005, the nations that were doing all these EOSAT observations, as well as ground and airborne observations, got together and formed the Group on Earth Observations, GEO. And so much like the IPCC, it's a cross-national, total global organization of the right agencies in each country. And you can see there in the 2019 summit, they had 105 nations for the latest meeting of it. And as you can see, our reps were from the agencies you'd expect, NASA, NOAA, and the Geological Survey. And so each nation's been sending these people to these summits every year. They did actually skip this year for reasons we understand. And their target, and it's taken them a while to get there, but I can appreciate it because it's a very hard problem, is to define a framework, which they're calling the GEO system of systems, in order to give a place for data to be sent so that comparable data can be captured and compared and, if you will, calibrated against each other. So it's quite an effort, like IPCC, taking a lot of help from a lot of nations. There is no big budget that GEO has, just like there's no big budget that IPCC has. They rely on the nation's governments to support their people and support the research agencies. All right, so that's where we are with the Earth OBS data. Now let's get on to what do we know most recently about the impacts of climate change, and we'll look at it in that same construct of the four spheres. And so just a real quick primer, as the greenhouse gases increase in the atmosphere, as you can see by the black arrow going up to atmosphere there, they also are going into the ocean. And in particular, CO2 goes into the ocean directly from the, from the atmosphere and is frankly adding to the acidification. So it's a problem in that sense too. But the greenhouse gases are there in the atmosphere. They bring about this increased hothouse effect, the global warming. And they also contribute to the ocean being warmed. And as the ocean warms, it gives back the warmth into the atmosphere. It's quite a cycle, and it's a much slower cycle than through air. But what we're trying to get at is, now that we've established that there's warmer oceans as well as warmer atmosphere, what are the impacts on the systems that we live in here? And so we're talking about, very specifically, understanding the man-made contribution to nature, if you will. In other words, there is rainfall, there is snowfall, there are floods, but what is actually the impact of man-made climate change on those things? That's been a big question, and obviously a lot of debate. And so that's what we're going to address. From the standpoint of the cryosphere, we're talking about addressing the man-made impact on these things. And the ocean, of course, is something that is fairly straightforward to understand. And in terms of the direct effect on our species, it's had already the most direct impact. And you're going to see a couple of examples of that. I thought I would tell you folks this because you're usually interested in knowing how science is working. In this case, as I did my research, I kept coming across in the very latest articles the word attribution. And it turns out that, and you can look this up in Wikipedia and so on, the term climate change attribution has now been established as a breakthrough technology by MIT. And there are specific groups of scientists who will tell you that what they're doing research on is attribution. And what they mean is they're trying to address the question that we all ask around the dinner table, which is, my gosh, that was a bad hurricane, or the thunderstorm that came through seemed like it was, there seemed like there were a lot more of them this summer. Do you think that's due to climate change? Well, this isn't necessarily saying that you could label each and every storm as to whether it's climate change or not, but it's coming to the point where whole categories of weather events, you might call them, are truly being established by modeling and comparison to be climate change caused. All right, so we're going to start now in looking at these impacts with the sea level, and you may remember this. It's the wonderful continuous curve of precise measurements of global sea level going back to the beginning of the spacecraft that first was able to do this continuously in '93, and that was TOPEX. And then came the Jason series of spacecraft. 1, 2, and 3 is now flying. And because we've had those up there with their down-looking radar altimeters looking straight down and doing very precise measurements of the sea surface, we've been able to establish without any question what is the sea level and how is it rising. And so if you looked back, you would see how this has turned upwards in the last 50 years or so to this slope since '93 when satellites started tracking it. And it goes right up to date as opposed to going to 2010. And when you take it up to date, you find that the slope has actually increased since 2010. So we have an accelerating slope that is about 13 times higher than it was for the first 10,000 years after we came out of the last ice age. So mankind has contributed enough warming now that the sea level is rising, and it's not just slowly anymore, it's starting to accelerate. And that'll have impacts. For example, hurricanes on land will be affected by a change in the sea level and by other things with climate change. The coastal regions are particularly hard hit, as we all know, by hurricanes. And it's notable that that's not just something that's a problem for the people on the coast. It happens that the way people migrate toward the coast around the world, that more than half the world's population lives very close to a coast somewhere. This year happened to be a record breaker, as you're aware, for hurricanes. And it wasn't the year with the most. 2005, when Superstorm Sandy hit, had 28 named storms and hurricanes. I think we're at 26 now, so we may get there yet. But we do have a record for the most that have hit landfall. And what I wanted to tell you about here is that we've now this year set the record for a kind that the scientists identify as the rapidly intensifying ones. And they have a specific definition of that, and there have been 4 of them this year. One happened just about a month ago in the middle of September. That was Sally, pictured here. Another one you may remember was Laura. That was in August. And the characteristic of these is, unlike the typical tropical depression to storm to possibly hurricane that takes a while and the models forecast it, in these cases, for whatever reason, as they approached land, they jumped much faster than others do. Instead of allowing 4 days warning or something like that, in these cases, it was like 1 to 2 days warning as to something that was a tropical storm ending up as a level 2 hurricane. And so they're very dangerous in the sense that the preparation time is much shorter and getting the word out is much harder. And the attribution scientists have studied the statistics, and they believe now that this particular category, rapidly intensifying, can be traced to something caused by climate change. Another impact, obviously, from sea level rise is flooding in the coastal areas. And maybe some of you have had an impact if you have a house at the shore or something like that, or know somebody that does. But I can't say at this point that I've known that a lot of Americans are particularly sensitive to their beaches and coasts experiencing a sea level rise. Certainly the surge from hurricanes, we keep an eye on that, and they haven't yet designated that as something attributable to climate change, but I wouldn't be surprised if that doesn't show up. But what you're staring at here is particularly empty and not that large area of Earth, the Western Pacific and Southeast Asia and China. And the reason I'm showing you that is that unbeknownst and thought about by most of us most of the time, there are literally tens of thousands of islands here. And we're going to talk about the impact on them because low-lying coastlands and islands are the ones that are getting it first. And there has already been a huge migration, again, that Americans don't seem to even know about due to sea level rise. The vulnerable 19 was a group of these Western Pacific and Southeast Asian island and coastal nations that got together and announced themselves several years ago, partly enabled to kind of plead with the wealthier countries of the world who are contributing per capita almost all of the CO2 and methane, as opposed to the poor countries, and yet they're the ones that are being impacted by it the most. So it's kind of like, here we are, see what's happening to us. Can you do something about what is causing that? Because you can. So here are a couple examples. I circled there in red a little country to the east of India, which from my schooling used to be East Pakistan, and now it's Bangladesh. And so Bangladesh is, probably most of you know it, is a very low-lying country with some offshore islands. And here's a farmer standing in the surf on top of the spot where his farmhouse was about 3 years before this. You can walk back onto the beach, which is actually his farm, and he's still got some of his farm left. But this is the typical kind of thing that's been going on in these low-lying islands and shore areas. And here's another one, another example. And so I picked some teenage girls here in the Marshall Islands. That's where that is, in the Western Pacific. And the reason I picked them, and the ladies may be noticing or guessing what they're doing, which is standing in front of a mirror and getting ready for a nice event, but I want to tell you what they're doing because it's a lesson. They're actually in Springdale, Arkansas, getting ready for that year's Marshallese Beauty Contest. This was 2016. And it was kind of a wake-up call to me. There's been a migration of a lot of these people that's come to the US because their islands are uninhabitable in many cases. Why would they come to the US? Again, something I learned recently that you may not know. There's a category of nations known as minor states of the US. And the Marshall Islands in the Western Pacific are a minor state of the US. It's not the same as a territory, but it's a step, a step in that direction. So they had a reason to come here because they were already partially citizens. But the lesson here is the migration is going on right now, which is kind of ironic when you consider the changing attitudes towards immigration. All right, so now on to the cryosphere. The thing that you're looking at here, you've seen before. It's a look on the two poles, looking down on the North Pole, looking down on the South Pole. And it's a quite striking example in the cryosphere of a contrast, where on the left, you have an ocean, the Arctic Ocean, surrounded by continents, and on the right, you have a continent surrounded by ocean. And each of them has their own aspect with regard to ice. The Arctic Ocean is frozen over for much of it for much of the year. And we're going to talk about exactly how much melting there has been. But what we call that frozen part is the polar cap. And we can now measure that polar cap, not just by looking down on the area of it, but by looking at the mass of it and understand it better. But just like an ice cube in a drink, if it melts, which the polar cap has been a lot more, into the water that it's already in, it doesn't change the level. So it doesn't impact sea level. But it is the canary in the coal mine, if you will, in terms of global warming being very real. On the right, you've got a continent surrounded by ocean, and it is a big continent. Tip to tip is well over 2,000 miles across Antarctica. And the white part is the ice that extends beyond the dark gray landmass, and it's all ice sheet. And it is, the gray areas are known as ice shelves. They fill in areas that are actually not on land and stretch across there, and we're seeing melting of that. And when that ice melts and gets all the way over into the ocean where it hasn't been off the landmass, it does raise sea level. So here's another view of the North Pole with the two kinds of the cryosphere there, and the two spacecraft that I've mentioned, or one of which I've mentioned, can do a couple of different things. GRACE measuring the mass of the ice sheet on Greenland and the polar cap in the Arctic Ocean, and Aqua showing us the aerial view of it as a spacecraft that goes around and gives us images, if you will, of aerial coverage on the ground year after year. So let's look at that Arctic polar ice cap first. And here we have, as recently as only about 40 years ago, the ice cap at the end of melting season, at the end of summer, it had still only melted enough so that a bit of the Russian coast there on the left was not ice locked anymore. And you compare that to 30 years later, roughly, where at the same time of year, at the end of the melting season, you had that much of the Arctic Ocean that had turned to water. Whole bunch of polar bears didn't appreciate that, I'm sure. And that's been going on increasingly for the last 40 or 50 years. And here's a curve of the measurements that we've made. And just like everything else, which is a graph that teaches you not to get caught in a trap of somebody comparing a 2 or 3 year period to another year, you have to be careful to look at averages, because Mother Nature works in a kind of a random, varied way, but inexorably changing if the change is coming. So you have to look at averages over an extended period of time and not compare some of these years like in the 90s there, where if you watched it for a while, you just say that's natural variation. So here we have, what is this, something like 42 or 3 years now, and the averages take you down at that rate. And as a matter of fact, we've just gotten past September, so NOAA's declared that the ice cap got to even lower than the right-hand line there and the second lowest on record. And the ice cap at minimum is roughly half of what it was only 40 years ago, which is decreasing at a 13% rate per decade. Again, this doesn't change sea level, but it does really emphasize the global warming. And the alarm is clanging. The headlines in the last year or two, 2019 also had a heat wave. Talk about a Siberian heat wave and the record temperatures in the Arctic. You may have read about this. There's a particular village in northern Siberia that hit 100, almost 101 degrees, which set a new record in the Arctic this year. But overall, and you may or may not know this, the Arctic region and Alaska have had far and away the most warming by all statistics of any place in the world since we've been watching these things closely for decades now. So the heating that's going on is not just global warming in the atmosphere, the usual way that melts it from on high, but it's things called marine heat waves. It's not a new term. It's a term that's been used by oceanographers for a long time to watch places that are warmer, sort of a blob of heat in the ocean around the world. And they were finding them once in a while, but very infrequently. The frequency and the occurrence of these has increased tremendously, and they're showing up in all the oceans now. And they've shown up in the Arctic, and they are responsible for a lot of melting of the polar ice cap. And so as the arrow here indicates, as it shows something coming up between Norway and Greenland there, they now have done expeditions and studies and published the discovery of what they call the Atlantic heat blob, which is an extension of the Gulf Stream. And you may remember the Gulf Stream does a nice job of warming the East Coast as it comes up and then heads across the North Atlantic and gives Northern Europe an unusually warmer climate than it would have at that altitude or latitude. But there's now a piece of that that has gotten so hot with a marine heat wave, if you will, that it's extended up towards the North Pole and is responsible for a lot of the current melting of the ice cap. In addition, they've been able to use satellite data to have a much better understanding of the interaction of ocean currents and the thermal water layers in the Arctic and the decline that connect to the decline of the sea ice, and have published papers that have confirmed, at least in the researchers' view, that there is definitely a changing ocean climate in the Arctic. And the AMS in their virtual convention this year with their papers, I decided to take this quote from one of them. Ocean warming has now overtaken the influence of the atmosphere. They were referring to the melting of the polar ice cap. So it's warmth coming actually from the ocean itself, from south coming up. All right, so now let's look at the other kind of cryosphere, the ice sheet, which when it melts does go into the ocean and cause sea level rise. This is a graph of what we've been able to measure with the different spacecraft now, going back roughly almost 20 years. And the average has been that huge amount of billions of tons of ice melting off of the ice sheet into the ocean, accounting for roughly 3 times the old level of sea level rise, which was 0.25 millimeters, which is what was essentially the steady state but slowly rising sea level for 10,000 years or so, until we got past the Industrial Revolution or into the Industrial Revolution. And so now Greenland is contributing at least this much to sea level rise every year. And when you combine that with the melting of the other ice sheet, the Antarctica ice sheet, about 1/3 of the current rise is due to the ice sheet melting. About a third is due to glaciers melting. And those are all over the world, but the biggest contributor is the Alaskan glaciers. They're by far the fastest melting glaciers, again, going along with what I said about the unusual warming of Alaska and the Arctic region and Siberia. And then the final third of sea level rise is simply due to the fact that when you heat a fluid, it expands. And we've been global warming the ocean for many years now, and it's been expanding. So we've got this inexorable sea level rise and its impact on humans that we've been seeing now. So we unfortunately have to even consider that the Greenland situation is about to get worse because of some recent findings. And so I'll tell you about this from an article that you can see the image there was just taken by the Sentinel spacecraft, the European spacecraft, in August. So it's very new data with very new research articles. And so what we're going to talk about here is the breakup of a very large glacier called the Spalt Glacier, or however you just say that in Danish. At any rate, what I particularly love to say is the name of that tongue that's sticking out there that the glacier is breaking off of, which might look like a, what am I trying to say? Not an island, but at any rate, what it is not land. It is frozen water. It's a fjord between two pieces of Greenland there, very large. And the name of it, if you can read it there, and I've tried, so I blew it up so you can all try. So everybody try to say this word. And I'll just tell you that every time I tried to say it, and I won't, I found that I sounded like the Swedish chef from the Muppets. So I hope you enjoy having that word now too. At any rate, that particular glacier is now threatening to break up a lot more. There's the front of it. And those little black spots are melted ice ponds all over the face of the glacier, going along with the breakup. And this has also come about in just the last couple of years. I called it the Siberian heat wave. It's also called the Arctic heat wave, with heating from the atmosphere and the ocean. And we've been monitoring it with not just our satellites, but we've had the OMG program up there around Greenland also looking at these things. And so way up north of the Arctic Circle now, we have got glaciers beginning to break up. And so they've modeled the impact if this glacier and others like it start to break off of the ice sheet into the ocean. And it's effectively doubled the effect of what we've already seen from that curve I showed you in the previous chart. And this would mean that if it were true that things stayed this warm and the breakup kept on at this rate in a widespread way, Greenland would contribute 6 inches of sea level rise all by itself this century. All right, so Greenland's threatening to get worse. Here's the home of the world's greatest ice sheet. Greenland would sit down, or would fit down on top of this, sort of surrounding the words Ross ice shelf there. That's sort of the size of Greenland compared to the ice sheet that is lying on top of Antarctica. The inner line is where the land ends, and those gaps that extend beyond it are these ice shelves. Last time we talked about the ice shelf in the upper left there on that peninsula, and that's the Larsen ice shelf. And I showed you the satellite identification and then tracking of a piece of ice that broke off the size of Delaware that's now about 200 miles away from what I showed you a few years ago. What we're going to look at right now is what's happening to a particularly well-known glacier to the left of the word Ross there. And the answer to this question we're going to address. It's known as the Thwaites Glacier, and it's got its nickname that was given it some time back, the Doomsday Glacier. So you see it sitting there on the West Antarctica coast at the front of an ice shelf that's connected to an ice sheet that's reaching out towards the water. And that glacier has been watched now for decades because it's very big and it's got an ice loss rate of 30% and has all by itself contributed 4% to the world's sea level rise as it's been melting. And it's looking like it might be melting and breaking up even more. And so NASA's been studying it, as you see here, with airborne surveys for over 10 years. And what they've been able to find by using things like ground penetrating radar to look through the ice to different thicknesses is that there's a giant cavity underneath the front part of this glacier. And the glacier, incidentally, where it faces the Pacific Ocean there on the left side, the scale is hard to understand this, but it's well over 100 miles across the front of it. And so in just the last couple of years, the United States with the British Cryospheric Research Institute or something like that, they've gotten together and used a research vessel that we have that's shown in the picture here to go back and forth for many months and do a really extensive mapping of the front of this glacier with the ship, with its sonar, and also by coordinating flights with radar, looking to penetrate through the thickness, and also a gravimeter like the GRACE spacecraft that can measure the mass. And what they've been able to conclude is that the underside of this friendly looking flat glacier extending out there is eroded away in a way that I described as kind of like if you flipped it over, it'd be like looking at a set of canyons. These are pathways that the warm water has carved under the ice that are at times 10, 20, 25 miles wide, big channels eating underneath it at such point that they're going to start to contribute to the breakup of this really, really large glacier. And so they've done the calculations to say that if Thwaites actually broke up and fell into the ocean, that alone could raise sea levels around the world by a couple feet. And the adjacent glaciers also seem to be suffering the same kind of warm water erosion. We could get many feet of sea level rise. So it's an area that is getting intensely studied. In summary, I'll just note that as my opening bullet and say it seems to be the greatest focus of study in the last few years in terms of impact, because it could have a very direct impact on sea level. And so they have modeled this in sort of best case, medium case, and worst case. And unfortunately, after running the models, they've found that the state of the atmosphere and the temperatures and the movement of things fits the worst case scenario that they've come up with in the last few years of doing their research. So that's a real warning there. Again, we could see raises of 5 feet or more. NASA is now in their research concluding that the two ice sheets are melting about 6 times faster than they were just 30 years ago. And finally, our favorite large UN agency, the IPCC, has put out a very special report looking at the cryosphere, even though they haven't put out a new assessment report looking at the entire climate. They hopefully will in the next year or two, but they felt that it was important enough because the cryosphere is changing to put this out and say the best case is 1 to 2 feet this century from melting of the cryosphere, and the worst case might be greater than 6 feet. And so these scientists are all studying things with their own data sets and coming to the same conclusions at this point, and it's pretty scary. All right, so I've gone through what's new in terms of climate change, sea level rise, and the impact on various kinds of systems like hurricanes. And I've also updated you on what's happened to the view from space. And now I'm going to briefly talk about what's next. And, okay, there's our friend. I told you I'd get to this. And so you might be scratching your head wondering what coronavirus has to do with climate change. Or maybe like me, you've been one that, as we looked around when we were all locked down, we said, you know, we're changing our behavior enough, maybe something real is going to change here. And so let's talk about that and what's been found this year. The impact, if there is one, indirectly from COVID is because our behavior changes and our emission of gases into the atmosphere is changing commensurate with that. And so with some excitement, many agencies and countries around the world looked at their skies getting clearer in the months where the world, for the most part, was locked down. We can remember that 6 months ago. And lo and behold, all those planes and cars and trucks not burning fossil fuels did have an impact. And so there were before and after pictures of various cities and urban areas and so on. But the sum total of what seemed to be measurable in the atmosphere was that not only did we have visibly less air pollution, but the one atmospheric gas that had changed markedly quickly was nitrogen dioxide, which is not a climate, not a greenhouse gas. So fast forward, and I imagine lots and lots of researchers have wanted to look at a longer term effect from this. I'd have to say, unfortunately, but that's a personal view, that the lockdown didn't continue as comprehensively for as long, but people got back to business. Plane travel and air travel and car travel didn't come back up to previous levels, but it did come way back up. And so it turns out that the lasting effect on our atmosphere, which would be to say on greenhouse gases and climate change, is really kind of negligible. And a large part of that is due simply to the fact that there's so much CO2 that we've put into it that not putting quite as much in for a few months is really only kind of a blip, it turns out. It was not enough that we didn't put in, and it wasn't for nearly long enough to actually give us a measurable effect on the CO2 level in the atmosphere. All right, on to the view from space and what's next for that. And I stress here that what's planned and the things that are on the book in the way of new climate change measurement satellites are things that are joint. There aren't any specific NASA-led things in the next few years. There's the next European Space Agency Sentinel spacecraft, which is the 6th one to be polar orbited from Vandenberg next month. And interestingly, the Europeans, along with NASA, wanted to name it for the NASA Director of Earth Science, Michael Freilich, who happens to be a Philadelphian and has been at NASA for decades and sadly passed away in August. And to honor him, the Europeans wanted to attach his name to their spacecraft. So that's being launched next month. And it will measure, it's going to continue on what Jason has been doing with an altimeter, but also with other instrumentation to measure atmospheric properties. France is leading a program jointly with NASA with help from the Brits and the Canadians called SWOT, and the acronym tells us what it is. It's going to be, for the first time, doing a comprehensive survey of surface water, not the oceans, but all surface water, lakes, rivers, creeks, in order to do a better job of looking at the water balance in regions, which will help us, even though we're already measuring soil moisture, to predict droughts and stress on vegetation and such things. And it's also doing some work on the ocean topography, especially near the coasts. And then finally, in 2022, like SWOT, will be a spacecraft launched from the Indian launch site down on the Indian Ocean in the south, so it can launch into a polar orbit there on an Indian rocket. And we are jointly working on 2 radar imagers, one that is a wavelength that we've come up with and are designing and building, and one that the Indians are, in order to do synthetic aperture radar imaging of the surface for climate change. And it's got a name that's easy to understand, NASA India NI synthetic aperture radar, NISAR. And it's going to map the land and the ice. And that's all I've found in the way of major planned climate change spacecraft. So let me kind of finish here by talking about NASA's priorities. And just like everybody's family's priorities are reflected in their annual budget, if they happen to be the kind of people that sit down and plan out a budget, they have to choose, you know, when and where they can take what kind of vacation, if they have a priority on that. But if you look at the amounts of money to be committed to things, you're really looking at the priorities. Food for people and families is one that's always big. In the case of NASA, they have several large categories. And you can understand now what the last few years with the new administration has in the way of what NASA's priorities are by looking at what's happened to the NASA budget for different things, whether they be deep space missions or aeronautical research or science of various kinds on Earth and elsewhere. And so I'll teach you just briefly here what I came to know in depth and practiced every year for decades as I sought out in the federal budget the customers that I was working with, like NASA and the Department of Defense, and learned to read their budgets at various times of year to be able to target what our companies were going to be able to compete for. And so it all starts with something called the PB. In February of every year, the next fiscal year's budget is initially introduced by the president, by the administration, as the PB, or the president's budget request. And it is just a request. It's not the end, it's the beginning. And so the Trump administration has been able, starting in February of 2017, to put forward 3 successive years of budget requests. And each time they requested a decrease in the Earth Sciences budget and a couple Earth Sciences spacecraft to be deleted. Fortunately, I believe for all of us, but certainly for Earth Sciences, in every case, Congress restored the Earth Sciences budget to offset those decreases completely. And so the net effect was pretty much, thanks to Congress and the momentum of ongoing research programs and developments, very little. And I say very little, and then I say the current statement for silence. You never get to hear the word climate change anymore, not just from NASA, but even from NOAA, the Atmospheric Administration, and from, you know, EPA or whoever it is. It's verboten. So it's very quiet in terms of what people talk about, and yet in terms of NASA's budget for Earth science, it's been left pretty much intact so far. That's so far. The fourth of the Trump years began in February when they put forward the president's budget for this year and the out years. And it showed a shift and a fairly significant increase in terms of the lunar program, which you've been hearing a lot about, Artemis. And so it's shifting the priority very specifically by putting their money where their mouth is for the lunar program versus science. Specifically, it was a budget request that raises the lunar exploration budget by about $4 billion and has a kind of commensurate takeaway from the science budgets, including the Earth science budget, of almost that much money. And so fortunately, at least from my standpoint, that isn't necessarily something that's a done deal. As I said, the president's budget starts the discussion, then Congress picks it up, and they have committee meetings and they have conferences and so on, and they finally end up with what is the specific agency budget for the fiscal year. And unfortunately this year, partly because of COVID, but not unlike most of the last of the recent years, we started the fiscal year 2 weeks ago on October 1st, and we started it with no specific budget being agreed to because Congress hasn't gotten there, not just with NASA, but with pretty much every agency. And so they started with a continuing resolution, which just resolves to keep the lights on and sort of sustain momentum until they actually have specific budgets. And so that's the way NASA is operating. They're just sort of carrying on. And I would say the good news is that, and here's a statement by the NASA administrator, again, just 2 weeks ago, where after his testimony to Congress, where I think for the first time, after they'd been asking for several years, he told them the exact bill that was going to come due for the Artemis program if we were in fact going to be able to put the first woman and a man on the moon by 2024. And it was, as expected, a huge raise in the Artemis budget and a drop in other things. And so the administrator has pointed out 2 weeks ago that that $4 billion is anything but fixed. The House actually has added back in $3 billion in their version of it, which is still not being discussed, let alone agreed to across Congress. So we'll see where things end up, and it probably has everything to do with the upcoming election. I'll just leave it at that. That's the priorities of the administration, and that's the current state of this year's budget. And the fact is that the clock is ticking towards 2024. So Administrator Breitstein is actually saying, if we don't get that $4 billion this year, we can't make that up in the intervening years. We've got to get the bigger budget this year, or we aren't going to make that date. All right, so we're at the end, and I want to try to give you just kind of a brief wrap up here. The state of the global climate change is worse in the last 4 years. It was headed there. There isn't anything, specifically that was going to change that from being worse at this point, despite such good intentions as the Paris climate talks in 2015. There was very little in the way of commitment, as in enforceable commitments with teeth, that came out of that. President Obama, for his part, did follow it up by going to the Chinese and the Indian leaders, the two greatest potential sources of new greenhouse gases in the world, and trying to come to some joint commitments with them. But then we had a new administration. And so at this point, things are just worse in terms of all the parameters and the impacts on people that have been happening and will continue to. And the direction that it's headed is even worse. You've heard me say over and over again, this and that catastrophe is now being linked to climate change, and the sea level rise seems to be accelerating, and so on. The view from space in terms of spacecraft and also all the agencies that can take the data and apply it seems to be okay at this point. As I said, despite attempts to take money away from NASA Earth Science, for example, it's been reinstated by Congress. And so far, from the narrow US NASA point of view, things are okay, and I don't actually have a comment about the rest of the world. But the direction of the view from space is very much dependent on budget priorities, and we'll just have to see where that goes. So finally, I would just point out that the underlying problem that we're going to have, and a growing problem we're going to have in terms of addressing global climate change in an adequate way, we really haven't gotten to that yet. We aren't doing the things that are going to be necessary to have any significant impact. We're going to continue having both a bad state as well as a bad direction in which we're headed. We can blame this, and this now is John Conrad's personal view. It's a lack of global leadership, a lack of coordination, a lack of commitment. There are many other things, But as I highlighted there, I think that without having the global leadership, wherever it might come from, I don't even know how we're going to get started on having all the nations of the world do what's going to be necessary to address this growing problem. All right. That's it, folks. I appreciate your attention. I hope you're still there.
We're still here, John.
Yeah.
And I think that there's a few questions in the chat from the group.
Okay, do you want me to leave this screen and come back to something? How do I unshare the screen here?
Up at the very top, view options. Click
Here
on
we
it.
go. I got it. Found it. Okay,
There you go.
here we are. I'm back. Hi.
And now go down to the bottom of your screen where the chat is and you click on it and the question should come up for you.
Okay.
You have to turn it up so people can see us. That's us.
Okay.
All right. Okay, we have a question here from Ed Demeraux. Is there any good news? Attempts to reduce greenhouse gases and having the desired effect. Yes, there is. You have to understand, I'm a retired guy. This is a part-time job. I have a narrow window and I love putting these talks together, but my answer is always going to be limited to the things that I happen to come across. In this case, what comes to mind immediately is the European commitments that were made this century, but quite a few years ago, to getting away from coal, for example, and getting away from and going towards nuclear in some cases and away from it in other cases of the nations. But the net effect of it is that the per capita level in US versus China versus Europe used to be quite high for all three. We were twice as high as the others per capita. So, let's all understand, we are the bad guys in terms of, for a long time, living way too whatever it is in terms of putting greenhouse gas in. The next was Europe. And Europe and us, I think, weren't too far apart until the last 15 years, at which point they've leveled off. And I believe it's probably because of the changes that they've made somewhat to their vehicles, maybe more stringent than ours, and also their mass transportation works a lot better than ours, but also to their, especially to their energy production in their power plants. And I'd have to say other major efforts, maybe one will come to mind, but I can't think of another one right now. Okay, Dave, COVID's caused a huge decrease in deficit spending. Has there been any projections from NASA yet on how this will affect their operations for over the next 2 to 3 years? I would have to say, part of that I just answered, I hope. I think NASA's budget, which has been treated quite well during this last administration, which is to say it hasn't been decreased in a real sense, it's grown at inflation or more, it needs to grow even more than that if we're to hit some very early date like 2024 with a lunar landing. Very great. So it'll have to be a significant uptick in NASA's budget. And depending on who the administration is, there may be a push for that. I know that the words that came, that I think I've mentioned here before, from the head of the agency and from Pence, who's head of the National Space Council, are that we're looking forward with Artemis to having industry cooperation, which is to say cost sharing, and also international cooperation, which coincidentally just today is able to be thought about more specifically because Bridenstine just published his list of countries that have signed up to the Artemis Accords, I think they're called. And so, and also today in the news was the head of the Russian Space Agency saying that they were not going to join because they view it as too much US centric. which is not the only shot across the bow we've gotten from the Russian Space Agency, who have joined hands with China mightily in the last 6 months in their space program. At any rate, I digress. The point is that with the list of companies countries, including a couple Middle Eastern countries, you can guess that they happen to be the ones that have been in the treaty game lately with Israel. They've signed up, and there have been, I can't remember the list, so I'm not going to try to tick them off, but you can look it up easily. Maybe another 8 countries. So maybe 10 countries have signed up. Now, a linkage between signing up for the Artemis Accords of cooperation and support, blah, blah, blah. I have no idea when money is going to be discussed there, or if there are going to be, if you will, joint programs jointly funded by multiple nations' budgets. So that's a possibility of how NASA can plus things up for the moon program. If we don't stay with the 2024 date, which I would suggest is possibly artificial, it was originally looked at as a program that could have us there in a more, let me just say, lower risk fashion by 2028. I'm not in any way against the moon program necessarily, but I am against believing in overly ambitious and trying to fund them goals. By going out to 2028, there'll still be a healthy amount in there for that kind of exploration, but it won't need to be anywhere near the amount of hundreds of millions of dollars more per year as it would with the 2024 date. So we'll just see if not only the priorities would shift back a bit towards earth science, but also if the Trump administration continued on, if they would be able to commit more money to NASA than has been in recent years. We'll just have to see. The election will have a lot to do with that. I think it's not quite black and white or a fork in the road, but it's not too far from that with regard to a commitment to using NASA, among other agencies, to address climate change. Okay, next is Kathy recently saw a report in the ozone hole growing again. Yeah, I think I may have seen that too, but like you, I don't remember either. Sorry, I just have to Google it. I don't see any other questions. Are there more?
Can I ask a question?
Sure.
Yeah, you talked about the climate change amplification due to the release of methane from thawing permafrost. Can you address the change in the albedo due to the loss of sea ice at the North Pole and how that will affect amplification?
It's very much noted all the times in the appropriate articles about the melting of the polar ice cap and the Arctic heat waves and so on. As you just suggested, I'll just say it's been expected, and then we've seen the result of the fact that when you go from the ice cap at minimum, still filling most of the region around the North Pole down to the continents, as was the case 40 years ago, to where it's only filling half of that for 2 or 3 months in the summer, you have 2 or 3 months of solar energy not being reflected off into space, but being captured by the atmosphere and the oceans, and warming the ocean directly as well as warming the atmosphere more, which is of course a feedback loop, which means more polar ice cap melting. And so it's expected that perhaps within a few years, if not that, then a few decades, we'll see the polar ice cap continually completely disappear in the winter. Frankly, paying for real estate and ports and leases on things is already started on the northern tier of the continents. It's ongoing, but the lack of ice reflecting back into space is a real measured effect, and you can see it in action. Thank you.
Thank you.
Somebody asks, are we past the tipping point? I don't even know what that is, to be honest with you. I can refer you to some books. Like Michael Mann is a Penn State meteorologist who's got a couple famous books. As a matter of fact, if you've heard of the hockey stick, some of you may have. You picture a graph that goes out for a short time and then goes straight up. Now you can sort of picture the CO2 to some extent, but that was the point. He called it his hockey stick diagram when he started to talk about it, I think about 15 years ago, and became quite famous for that, wrote a couple books that I have. And so that's not a tipping point, it is a knee on a curve. The tipping point is, if I understand the term correctly, hopefully not something that we've hit yet, but it's a point where whether it's total melting of the polar ice cap, as well as breakup of rapidly increasing numbers of facial glaciers on the ice sheets, especially Antarctica, and the sea level rising not 1 to 2 feet by the end of the century, but a foot every 10 years or something like that. That's going to that's the kind of thing I think of as a tipping point for sea level rise, because it would lead to mass migration of literally half the world, some of them whom live right on the coast trying to move back, but there's no place to move that's right behind them. So they have to move further, or the prices change for all the real estate, and then everybody's got to shuffle. I mean, the things that might happen are kind of extraordinary. So I'm looking again here. Yeah, I don't see any more questions. Does anybody have them? Anybody have any questions?
Yeah, one more. Just you mentioned aircraft with NASA. Do they also have balloons too to do research with?
I know the answer is yes, but I don't know any more than that. I just saw one in an article today, actually, that I printed a hard copy of. It may have been NOAA, but I think it was one of the two agencies.
John, I have to tell you, we peaked at 80 attendees. I think you set a record for our club.
That's great. That's
Thank you,
great.
John.
You're famous, John.
Appreciate you guys, inviting all the other clubs. That was great.
Got a lot of good comments from YouTube. We're up to 50 people at there at one point, and they're asking how we can do this again. So
Yeah, so
Super.
Keep doing it.
Super.
Keep doing
Well,
Don,
we
how
change
many
John to
people
his
did you
desk and make
say?
him do another one.
we had 25 people on Zoom, and we had 55 on YouTube at the peak.
Did you have a question? B?
Wow,
Okay.
B?
I thought you said 80.
Yep.
Yes, thank you.
Well, again, John, thank you for a fantastic presentation. That was wonderful. And we hope we'll get some more input from you on this very subject in another couple of years. I think it's as much as this is accelerating, we'll probably have to revisit the subject again.
Yeah,
And again,
let's hope we get a handle on it. Let's hope we start to get a handle on it. Great to talk to you folks. Thanks a lot.
Thanks, John.
Thank you,
Thank
John.
so
Thank
much.
you.
Thank you.